Welcome to the Apex Expo Career Panel. I'm John Mitchell. You can go to the next slide, Aaron, just so they can read. I'm the President and CEO of IPC. We're very excited to be having this career panel with you and some guest speakers as well. And we look forward to an exciting 90 minutes that will include hopefully some live questions and answers with you, as well as we have some of our industry members joining and sharing with us. And then at the end, we'll also have a raffle, right, Aaron? You're on mute.
We will indeed. Hello, everybody. This is Aaron Burney. I'm Program Manager for IPC's Education Foundation. We will have a raffle. So as long as you signed up in the list, I will cross-reference those with the names signed up. And I know that some of the names don't link up perfectly, so I'll go off the registration and hopefully they're in attendance. You do have to be in attendance when we announce, so please stay on. That'll be later on in the event.
Very good. So without further ado, we're pleased to have you all. We've got university and high school students and educators joining us. So thank you for joining us. And we look forward to your questions and comments. But as we get started, Aaron, can you flip over to the agenda? I think is the next slide. Is that right? Yeah. So this is the welcome remarks. I've got another minute to finish up here before I'm late. After this, giving an overview of the electronics manufacturing industry is Steve Puddles, and I'll introduce Steve here in just a moment. Following him, I'll introduce Dave Hillman, who's going to talk a little bit about the future of the industry. And then we'll get into our talk a little bit with each of our panelists so you can understand their journey, how they've gotten to where they are. And then we'll do some live Q&A with them. And then Aaron will share a little bit about some IPC programs for high schools and colleges. And then we'll have the raffle giveaway and then close up here. So that's our agenda for the day. So if you go to the next slide, Aaron, let me introduce, it's my pleasure to introduce Steve Puddles. Steve Puddles is the reason I'm here today. So it's always a pleasure to introduce.
And no, I'm not his father. Okay.
Yeah, so Steve was the first member of the board that I met when I was interviewing for this position. And so Steve has been a stalwart for the industry. He has been not only served as CEO of many different organizations in the EMS space, but he has also been on the IPC board for nearly 2 decades. He has served as chair, vice chair, secretary, treasurer, and has done many great things and is largely responsible also for our certification program even existing in its form that it does today. So with that introduction, let me turn the time over to Steve.
I'm not going to cover my background again, other than the fact that, 40 years ago when I graduated with my undergraduate degree, I looked like an engineer, even though I probably would have been better just playing one on TV. Let me get right into it and talk about the electronics manufacturing industry and electronics in general. Most of the people that are in college today or in high school, or everybody on this call, other than your professors and your teachers, probably don't remember a world that didn't include these logos in it. Your cell phone, your games, your computers, your tablets, the things you do with your exercise equipment. Everything today is all about electronics, and these are the things that that are manufactured in extremely high volume, where cost is probably more important than some of the quality and some of the durability. But you couldn't imagine your life without at least 5 or 6 of the things that you would put in this category. So given that, even though some of these companies that are up here with their logos have been around for 100 years, there's a subset of logos here that you probably know all of them, maybe with the exception of 1 or 2 or 3. But I can't imagine that even within the last the 10 years as you're using electronics products, as you're growing up, that you haven't been exposed to all of these brands. And there's brands on here today which represent companies that started long time ago that were mostly products with no electronics. I'll use an example. The second on the top line, the second from the left, Nikon, started in optics and lenses and cameras that probably didn't contain any electronics when they started. Today, it's nothing but electronics. Now you have the electronics that you are exposed to every day, exposed to sometimes not every day, but you don't even recognize the fact that there's electronics surrounding you. If you were born from 1998 to today, you never got a new car that probably didn't have a bill of materials that was 30 to 40% content value of electronics. From your computer on board, from your dashboard, from your heads-up displays in some of the cars, the sensors, the parking, the cameras. It's incredible. I remember when I graduated college, there was no electronics in the car. So just think about where the world's gone in 30 to 40 years. You see things every day. Your lights, traffic lights. You see the robotics. I'm showing tractors. You look at the logos at the bottom. You get on a train today. The electronics controls, the switching systems in the tracks. Obviously, airplanes, rockets, missiles. But the most important is, what would we do if you went into a public restroom and you sat down and you stood up and you had to flush your own toilet? You wouldn't know what to do today. So, there's a case of something you see all the time, and you just take for granted that there's an electronics content in a product that you would never have guessed, 20, 30 years ago would require it. So you get to see that the electronics touch every part of your life. And then if unfortunately, if you have, someone that or yourself have been in a hospital, you've been surrounded by electronics in the equipment they use to perform tests, in the equipment that they use to monitor what's happening. And obviously the military today, the guidance systems, the airplanes, the rockets, the missiles, things that are meant to have very specific functions, sometimes lethal functions, are controlled with electronics to make sure that the functionality of that product does what it's intended to do, but doesn't do what it's not intended to do, which is equally important. But here's where electronics are not only important, but they're highly critical. The workmanship standards, the reliability, the performance life of the products are in a whole different world than when you buy your Apple Watch. So it just kind of make a contrast there. So how do products get built? Products are really built, electronics products and electromechanical products are really built by three types of companies. Most of you are familiar with the OEMs, the original equipment manufacturers. They're the ones that, in addition to building and designing products, are also the ones that are marketing it, distributing it, and they're looking at new product design and new concepts. But the electronics manufacturing industry is unique because most finished products, and I don't like to read bullets, but are not manufactured by the OEM. You can see the highlighted, yellow highlighted section there. So who are they built by? Well, first of all, we have the segment of that industry that's near and dear to my heart, because I entered my first EMS company, Electronics Manufacturing Services Company, in 1985. I attended my first IPC meeting in 1987. We didn't have a name. There was no EMS industry. We were contract electronics manufacturers. We were electronics contract manufacturers. Some people referred to us as board stuffers because we stuffed parts in boards. But we sometime around 1989, 1990, we actually had what has become the EMS Management Council of the IPC. We had a meeting where we actually spent 4 hours debating whether EMS should be electronics manufacturing services or electronic manufacturing services. And I still remember the two people who argued with each other for 4 hours over that. So it's just a little quick history for the IPC. But the EMS companies, it's a worldwide industry. It's very interesting because as you look at the EMS companies that are, huge volumes and a lot of consumer electronics, the ones that are all around the world, especially in the low-cost regions like Asia, these are, they're very specialized in that segment of the industry, the high volume consumer and products like that. But the companies that I've worked for, as a contrast to that, have been U.S.-based companies that specialize in medical and military high reliability. So there's a lot of companies, that are in between, that have different facilities in different parts of the world. But the amount of electronics manufacturing that's done by the EMS companies represents, the EMS supply chain. We are the biggest outsourced industry in the world of any industry. There's another segment that most people are not familiar with, but if you know, a good example is your cell phone. You know, there's in the cell phone, there's a transceiver, a transmitter or receiver that operates at a certain frequency that may be the same for every company that makes a product for that cell carrier that can operate at a certain frequency for cell towers in a certain region of the world based on who that carrier is. So who actually manufactures that? Well, there's another segment called ODM, Original Design Manufacturer. And the ODM may design and build a subsection of any product. There's people that specialize in medical ODM where they may build an X-ray module that's used by 5 different X-ray manufacturers around the world. But the cell phone is probably one of the most widely used. The laptop computer, there's only 2 companies, I think, that are still making the motherboards. The main, I guess I have to use the politically, you know, current, the main board that are used by all of the laptop manufacturers. The cell phone transceiver or chipsets are used by all of the manufacturers because they have to function the same. So there's companies that specialize in designing and building a subsection that would get used for all these. So now let's talk about starting at the finished product and working backwards. In the blue space, I don't know if I don't like not having a pointer like I would have if I were standing up in front of you. So this whole virtual thing's not working for me real well. A finished product, no matter who's building that product.
Your cursor, Steve.
Okay, good. All right, that's helpful. That finished product is made up of an entire worldwide supply chain, depending on what that product is. And that worldwide supply chain, each one of these boxes, each one of the orange boxes up here on the left, each one of these blue boxes that feeds the final product, all of them have special technology requirements that, you know, I'll get to in a second, kind of a list of all the different STEM programs that you may be involved in today, or you may be involved in a few years, depending if you're still in the high school. But each one of these pieces of the supply chain have their own technical requirements that not only feed that piece of the supply chain, but the equipment that manufactures that piece of the supply chain has its own supply chain as well. So there's so many opportunities within the electronics manufacturing world for science and technology and engineering and mathematics, and it's a lot more than just what it takes to build a product. It's what it takes to build all the things that go into a product. So what makes up an electronic product? We have the printed circuit board, and I'm making some assumptions that if you're on this call, you probably know what a printed circuit board is, and the fabrication of that circuit board requires chemistry and chemical engineering and material sciences, and you have laminates which are made up of all different kinds of materials, and you have plating, and that is an additive process, and then you have etching, which is a subtractive process. You're starting with a copper clad laminate, you're removing and leaving the traces, as opposed to additive where you're putting the traces on. So you have so much technologies just in that one board alone. I'm sitting here pointing at it and I realize nobody can see my finger. Components. You have semiconductors, you have passive components, you have connectors, you have all kinds of hardware and things that go into that. And each one of those has its own manufacturing and its own supply chain. Cable assemblies, connecting things, interconnect. You have the terminations can be connectors, it can be terminals, it can be, you have wires that's extruded and have different jacketing and different materials. So, you know, what I'm showing you here is that whether it's plastics or metals that make up your cases, 3D printing, which you probably all take for granted, you know, up until a few years ago, if you wanted to do a prototype or a mold, you had to do injection molding, you had to do castings, you had to do processes that took a lot of time. Today, if you can put it on a CAD program, you can make a part with a 3D printing process, and you can be building your prototypes, you know, in 24 hours. It's unbelievable. There's epoxies and adhesives that are conductive, so the joining of things together now becomes part of that circuitry path. And you have process materials that make up solder, fluxes, all kinds of products used in cleaning and joining. So coating. So there's all these. You have chemicals. You have mechanical parts. You have electrical parts. You have all the pieces that make these up. And if I know it's a 10 to 15 minute introduction, but there's such a vastness of opportunities in the world of electronics manufacturing that I know I didn't know about when I was, going to school. The other thing, and this is where the IPC comes in. First of all, you have the electronic manufacturing that I broke down below, and you have your OEMs, your ODMs, your EMS, and they're manufacturing the product. That product is also made up, in addition to the hardware that people are putting together, the firmware, which is the software on the electronic parts. It's actual software. It's applications that you're familiar with. It's configuration of all of those products. A product that you build, a good example is a printer that you have on your desk. That printer, if it's used in a different country in Europe, it may have a different power supply. It may have, it may have other requirements for local regulations. So we come over here to the right-hand side, and we, the IPC, like to not only think, but we are the standard organization for workmanship, for what goes into the design and the layout all over the world. People are using our standards. We have millions of people working for thousands of companies that are members of the IPC, and then we have millions of people that are not members of the IPC that are using our products. They just pay more for them. You have government agencies. You have regulatory groups that are sponsored. There's areas in Europe that you can't buy a product that hasn't been worked on for by CSA or CUL or UL. So there's all of these agencies have technical people working for them, designing their requirements, creating regulations, creating specs, creating legislation. So it's just a vast amount, millions and millions of people around the world that are all part of this thing that we call the electronic supply chain. So if I were in front of you, I would say, show me by hands, how many people 5 years ago, 10 years ago said, I can't wait till I grow up. I want to work in electronics manufacturing. I would maybe see one hand go up, and then I'd ask them if they were really telling the truth, and it would go down real quick. I remember when I was in high school and I went to my guidance counselor, and they said, what do you want to do? I said, well, I want to go to college. What do you want to be? I have no idea. Well, you're good in math and science, and your English scores aren't going to get you very far. So why don't you be an engineer? So I figured, I didn't want to spend the rest of my life, driving a train. So I had to look up and see what engineering was. I went to school, and I went to 3 years of school for chemical engineering before I decided this is not for me. So, I never thought that I was going to get into industrial and manufacturing engineering and get into the electronics manufacturing business. But here we are. What's important, and to kind of summarize, what you're going to hear today and where you're going to go, everything in the world relies on electronics. And what you guys are doing, the whole idea of a technical education, which I think is, the most incredible experience, and sometimes frustrating as hell. There wasn't a time where I had a week in college where I said, what am I doing to myself? But I look back now, and it's, when you talk to your friends who are taking everything but engineering or science, they don't have an experience like you're having. It's not as hard as you're having, but it's also not as rewarding. Everything that you're doing in the STEM program is the foundation for everything we're doing in electronics design and manufacturing. It's not only, about the money, because you will earn a great living or a good living. You're never going to have a problem feeding your family, and there's a lot more opportunity if you're inventing things and creating things, but it really depends on what you want to do. But you're solving the world's problems. I had a physics professor who once said to me, if you can invent the world's most comfortable pair of shoes, you'll never have to worry about making a living, right? So it's all about, what are you doing? What are your products doing? What are you doing in that supply chain to make the world a better place? And if you look at all of these disciplines that I listed, and it's obviously only a subsection of everything that's out there, all of these things can get you into a career that is part of this electronic manufacturing industry chain. And it's extremely rewarding. There's always times where I said, well, I could have been a lawyer, I could have been a doctor, I could have done this, I could have done that. But I really look back, and it's been a great career. It's been a great life. I've gotten to work with a lot of great people, and I've gotten to work with a lot of great people and work for some great companies. So I wish you all well, and I hope I didn't do anything to change your mind away from electronics manufacturing. The IPC is a great organization. You'll hear some great programs today, and I look forward to having you join me out in the industry. Thank you very much.
Steve, while we're shifting over here, there was one question about how do R&D facilities blend into that hierarchy of companies that you were going through?
So, I talked mostly about the manufacturing, but everything starts with the design to develop product. The OEMs have a lot of their R&D facilities, and if that's the path you want to choose, you're going to probably be meeting with different people within the same companies. But a lot of the ODMs and the EMS companies also take part in that design. That design supply chain as well. We do printed circuit board layout for customers. We do some RF design and RF programming. So the same when you're a double E electrical engineer, there's people who develop products using electrical engineering, and there's people who would use the electrical engineering to develop pieces of a manufacturing supply chain. So it's really based on what you want to do and where your interest lies.
Very good. Very good. Thank you. All right. So next on our docket, we have Dave Hillman, who is a fellow at Collins Aerospace in materials and process engineering. Dave is also one of IPC's Hall of Fame members, as is Steve, and has done a lot of great work in various technical committees and a lot of our standards committees, and has served the industry very well across the globe. So without further ado, Dave, take it away.
All right, well, thank you, John. So Aaron will pull up my presentation, but I tell you, folks, I was a little bit confused in where I should be, because I looked at what Steve was going to do, and Steve kind of set up a great presentation of what, and I looked at the panel that's following when I get done talking. They're going to give you a great section of how. So I thought, why don't I just kind of fill in the why? And so my mentors have taught me, if you're going to do a presentation, I'm going to present. So you're not going to see a lot of words, but you are going to see a few pictures. And we're going to walk through this and have some fun. So Aaron, if you go to the next cell, please. So this is me. As John said, I'm Collins Aerospace out of Cedar Rapids, Iowa, middle of the Midwest. Have been fortunate to become a fellow here in Collins Aerospace, and very fortunate to be a recipient of our Hall of Fame. 37 years in the industry, so yeah, I'm an old fart, been around a while. Yeah, that's me. I'm a kayaker. I love whitewater kayaking. You'll find engineers get to do some pretty crazy things in their off time. More importantly, though, I'm heavily involved in our STEM program. Over the years, I've had over 130 students where I've mentored, so I've gotten to see and insights on some of what the students are. Hopefully, I'll give you some of the why, what you're going to go through as you kind of think about a career. Next, please. So, you're going to get this question. As Steve said, I remember getting it asked in high school and got asked 3 or 4 times in college. So what are you considering for your career? And I can tell you the first 2 things that go through your mind are, well, how do I know? I didn't know what I wanted for breakfast this morning. So how am I going to answer that question? And secondly, here's a guy sitting here giving a presentation that was around when mammoths roamed the earth. And how is he going to tell me what I ought to know or where I should go? So I'm not going to do that. That's what the panel behind me here, when you see them today, they're going to give you their journeys, and you're going to get to see a lot of different things that should inspire you and give you some ideas of this question isn't nearly as daunting as you might think. So next question, or next cell, please. So the one thing you need to understand when you start thinking about your career is you need to understand the past. There's a saying that, I can see into the future because I stood on the shoulders of giants. And everything we do as engineers and everything we do in the industry, somebody did something before us that allowed us now to go farther and make more advances. And I always like this picture because it's really clear that these folks don't understand their past. If you look at the 2 individuals in front of this camera, I don't know what they're trying to accomplish, but pushing on the tractor might not be the easiest way to get it out of its predicament. So one thing to just keep in mind as you think about your career is think about the past. Where's the past going to lead me to my future? Next cell, please. I was watching Discovery last week, and the Discovery Channel had some things on flight, and they said something that caught my eye and stuck in my brain, and I thought it fit well for today's. What you're looking at, if you don't recognize it, that is the Wright brothers' first flight down at Kitty Hawk. That's their first plane. There was a young man who was about 5 and was on the beach and got to see this fly. And he lived long enough, Aaron, if you go to the next cell, to see this creature. So imagine in your lifetime, you got to see the first airplane ever. Flight, man couldn't fly. And then 60, 70 years later, you get to see the space shuttle go up into space to explore space, to hook up to the space station. In that one individual's lifetime, he went from something that human beings couldn't do to something that none of us would have ever imagined. Can you see that someone said, do you want to be an astronaut? He didn't even know what space was at that point. So in your career, you don't really know where you're going to go. What you need to be is open to possibilities. And the panel, I have no doubt the panel behind me is going to talk about why I was going direction A and suddenly I went direction B. And being open to those changes is huge because we just don't know what's coming, depending, as like Steve said, technology changes so fast and it's so fulfilling. If you go to the next cell, please. Same thing here. This, if someone, in fact, I've no doubt most everyone in the audience won't recognize this, but the cell on the left, that is the Redstone rocket series. The Redstone rocket was what we used as trying to figure out how to put a man into space. Eventually, the Mercury program went from Redstone to Jupiter to Mercury, and that was where we put our first US person into space. And later on that changed around. You can see our Redstone rocket here. And rockets were a little bit tricky. There's some electronics on there, and there's a whole lot of mechanics and things that we were trying to understand. Next cell, please. The one thing you need to realize in your career, things don't always go the way they're supposed to. We make mistakes and you learn from mistakes. And ideally, you'll find an employer or a culture that understands that making mistakes help us get ahead. And we don't use those as beating sticks, but rather mistakes teach us the places where we should go. There's a famous saying from Thomas Edison that said, you know, you failed 4,000 times in trying to make the light bulb. And Edison replied, said, no, I just figured out 4,000 things where it won't work. And so you got to go to 4,001 to make that work. So don't be afraid to fail. And you're going to hear about that. The panel maybe have some failure stories for you. Next, please. So as Steve said, I'd rather much do this in person, but with COVID, we'll make do with what we've got. So here's a wonderful view. If we were all standing there, I'm on stage walking around with the mic, I'd say, who recognizes this landscape? Where has anyone been here? Has anyone seen that? And some folks might start chuckling. Others will go, well, it kind of looks like Southern California. No, that's the Sahara Desert. Next cell, please. Well, what that was is Mars. And if you paid any attention to the news, and we at Collins very much have, we have put Perseverance down on the planet. While one might think, well, you know, we put rovers on the planet before. Percy is the size of a Volkswagen. Think about taking a car, launching it from Earth, all the way to Mars, and then I want it to land without being in a million pieces. The reason Collins is pretty happy is on that mast stem where the top camera is, that's our optics that Collins put together, and we are very privileged to be part of that program and our exploration. Percy is going to do things never imagined. It's going to be able to go around the planet, look at different things, answer questions that we have asked from an engineering and from a science standpoint for a long time. But what's even cooler is I know some of you in the audience, you deal with UAVs. You've got the little remote flyers that you pass around. Percy has a buddy. Percy's buddy is Ingenuity. It's a little helicopter, and they are going to fly it. And while that may not seem to some of you a big deal, the atmosphere on Mars is not the atmosphere on Earth. Can we fly? What's it take? How do we do this? The science that's going to come out of this is amazing. In fact, if you've watched any of the news, right now Percy is just kind of trudging along. The last report, it had gone about 78 meters. They're looking for a spot to drop Ingenuity off. And at some point, we're going to give it a fly and see where that goes. So think about your passions. You know, do you like video games? What kind of things are you into as for hobbies? Almost all of those hobbies can become a career, and a career that you're passionate about and have fun with. So keep that in mind. Next, please. This one, I put this out for some of the older crew, but this one's kind of fun because it relates back to Collins Aerospace and our old division of Rockwell Collins. What you're looking at is a GPS station, and GPS is Global Positioning Satellite. And Collins was around when GPS was first coming into being and invented. This GPS station will get one signal. It has bucket seats. As you can see in the front, there's an air conditioner to keep all the electronics cold. And more importantly, there are casters underneath the bottom. It is a mobile GPS. We could go down the hallway as far as the extension cord would let us go. It was great. We couldn't believe what we could do. And if you go to the next cell, please. What we have today is you see a picture of a handheld GPS device for the warfighter. Now we carry around GPS in our cell phones. If you're into outdoor activities, a lot of people have GPS applications that we just hang on our belts, put in our pockets. It wasn't that huge 400-pound monstrosity we were wheeling around the hallways. In fact, I'm going to take a trip on the Missouri River here in 2022 out in the middle of Montana. My only connection to the real world will be the GPS signal. So that's how involved we've taken these electronics and allowed them to do different things in our lives. You could be part of that. In 60 years, we went from that very large, clunky one satellite reader to something that you can have in your hand. That's where your future could take you. That's the kind of things you could be working on. Next cell, please. And I know John will get a kick out of this because this is electronics 101, and my son and his friends who look at this can't quite believe it. That's a cell phone, folks. That is the first bag phone from Motorola. And if you think you complained about how heavy your cell phones are now and that the screen isn't big enough, try not only, you don't have a screen, but have something that weighs 5 or 6 pounds that you've got to carry around. And the coverage was horrible and the battery didn't last very long. But we had a mobile phone. You didn't have to go over to the phone booth, which nobody in the audience probably knows what is today. And we're stuck with that. Next cell, please. Now we have these wonderful devices. And not only is it a phone, but we have figured out, and it started out as a phone. You saw that bag phone, but then someone had the vision to say, well, why can't I get the weather on here? And why couldn't I have GPS? And why can't I play my music? And why can't I do, it was just, why can't? Let's try this. Games, Clash of Clans. If that's my phone, Clash of Clans is on here somewhere. So we've taken what was just a phone and envisioned what else can it be, and just taken it to new heights. Next cell, please. And one of the things, the other rules, and I'm hoping the panel talks about this, is that sometimes you got to keep an eye on the bigger picture. So what you see there on the left is, I believe, is an it's not an F-15. I think it's an F-15, not an F-14, but that was what we call a weapons delivery system. If you look to where the red arrow is pointing, that's a weapon system. At this point, they're supposed to be connected. And as you can tell, the sailor is not very happy about what he's seeing. And so we have to keep, as engineers and scientists, where are we taking our products? What are we doing with them? How do they relate to the public? And how can we make sure that all that fits a nice, tidy kind of bundle? Next, please. So lastly, the question in the beginning was, so what will the future look like? I haven't a clue. I have no idea. But I do know that if you have an eager mind, you're going to be, and you're passionate, you're not afraid of hard work, and you can take some calculated risks and aren't afraid of change. And the panel is going to talk about that you will have an unbelievably amazing future ahead of you, and a career in electronics is the place to do. So with that, thank you. And I'll, John, turn that back to you, and we'll let the panel have some fun.
So I guess I'll start. I'm John Mitchell, as I mentioned, President and CEO of IPC. I didn't even know IPC existed when I started my career. In fact, I didn't even know they existed probably halfway through my career. I just knew that people made standards. I started off as an electrical engineering student in university because I enjoyed science, math, and things like that, STEM types of activities. My first job was, what was my first job? I was actually I actually did some software programming initially. And then I got into developing GPS systems. Back then, we built navigation systems for the vehicle at Alpine. From there, I got an MBA at Pepperdine. And then I went over to Bose, where hope you guys know what Bose makes. Bose makes a lot of cool stuff, sound equipment and things like that for your listening enjoyment, but they're really a research center. Their primary goal is research, and they just sell sound stuff to pay for the research, which is really kind of cool. So a lot of MIT guys there doing some really cool stuff. And then after that, I got my doctorate and I moved into the nonprofit sector. I actually ran a collegiate honor society for a few years, not anything to do with electronics. And then I was able to move into IPC here and became the CEO. All along my career, as they were mentioning, you look for opportunities and I took them. So that was kind of my path. And it's been a blast. And the great thing about my job today is that I get to use a little bit of everything I've done. I traveled internationally, worked with international groups. I did electrical engineering. My doctorate's in education. And so we do all of that stuff at IPC. So it's really kind of cool that it's kind of the juxtaposition of everything I've learned. So with that, let's go to Sarah. Is it Chapleski? Did I say that right, Sarah?
You're close. It's Chapleski.
Chapleski. Hey, yeah. Congratulations. I saw you won one of the giveaways, didn't you?
Yes, I did. Yesterday, I think.
Good job.
Yeah, thanks. So I'm Sarah Chapleski. I'm a senior engineer and master inventor at IBM. Currently, I work on qualification, reliability, and quality management of our printed circuit boards. So I work with our PCB suppliers to make sure they're meeting our needs, creating reliable boards for our clients. I joined IBM in 2014, started my current role in 2018. Before that, I was working in a failure analysis lab, basically just doing a lot of materials testing and characterization, which laid a good groundwork for my current role. Prior to that, I worked for another company for a little over a year, Kimberly-Clark. And then before that, I got my master's and bachelor's degree, actually in biomedical engineering from the University of Wisconsin-Madison. So I had not intended to go into the electronics industry. I was focused on biomaterials. So then for family reasons, I ended up moving to Rochester, Minnesota, and that's when I got involved with IBM. And working in the materials lab there was a fit with my background in expertise in materials. So that's how I got started in the industry, and then just stuck with it from there.
Hi, everyone. My name is Paige Feet. I am a fourth-year electrical engineering student at Michigan Tech. Go Huskies. How I got into the industry was a little different than everyone else. I planned to go to school to be a biomedical engineer, similar to Sarah. And I started taking my courses, and it was a lot more electrical courses than I thought it would be. And then my first internship back home was working with surface mount technology and those lines. And I was like, this is interesting. So the next year I go back to school. I changed my major to electrical engineering. I really enjoyed circuits. And then I found Calumet Electronics at Career Fair, and I thought that they did SMT stuff similar to what I was familiar with. I was in for a whirlwind and found out that they actually make the circuit boards and do PCB manufacturing. I worked for Calumet from January to December of 2020. I qualified a pre-clean line. I worked R&D for them. I worked with their manufacturing lab at Michigan Tech. We teach students how to make PCBs and a few other various projects.
Hello everyone, my name is Jie. I currently work in Apple as DFM Manager, Design for Manufacturing. It is general engineering practice of designing products in such a way that they're easy to manufacture and makes all the crazy ideas into practical products. I've been with Apple for 3 years. Before joining Apple, I worked in Qualcomm for 5 years as packaging engineer. Well, packaging engineer is not USPS packaging, it's for the chip packaging, not the potato chips, but the silicon IC chips that integrate on the substrate to achieve the functionality of the electronic products like the phones or computers. Qualcomm was my first job that after my graduation from UCLA Materials Science and Engineering. In school, I focused on the material property of solder alloy that aligned well with the silicon packaging in the semiconductor world, where you can get lots of hands-on experience on the process and develop the leading edge technologies. The engineering work, especially on the process development, finding out the smartest way to build a product, debugging the issues, investigating the root cause, really keep me in the engineering job. It's fun and proud when you see your work turns into real products. And those moments cheer me so much that I hear the comments on like how the products change people's lifestyle, how it improves the work efficiency, like how it keeps everyone healthy. So I'm pretty sure like everybody here will get excited getting into electronic manufacturing industry like I am.
So I'm Daniel. I work for Summit Interconnect. I went to Cal State Fullerton. My degree is a little bit different. I actually got a degree in psychology while doing a bunch of side stuff. So I kind of started off at the entry level because I kind of knew a person. They got me a job, so I started doing data entry. Then I moved over into planning, and kind of when I was in that transition, that's what kind of like made me get more invested in the electronics. Before it was just kind of, I was kind of doing what I thought was fun. The math was fun, doing all the, all the setups for them. And then as I moved into planning, eventually I started to learn more. And then that's how I got to where I am right now as a process engineering. So right now I'm like responsible for routing, lasering, plasma, and it's just been really fun. Like seeing the tangible stuff that we get after when we're building them is just, I don't know, the electronics has just been really fun.
All right, so my degree is different. Yours isn't different. So I'll go to the punchline first. I'm not an engineer either, but I've got a degree in finance and marketing from Loyola Marymount. Taking it back a few steps, I grew up in the very hot desert of southeastern California on the Mexican border. Started my career driving open air tractors in 120-degree weather, and figured out that that's not what I wanted to do for a living. So got an internship at Douglas Aircraft in Long Beach, which is now Boeing. And learned a lot of things, including that I didn't want to be a part of a 50,000 employee company. So I looked for something a little smaller, interned at an investment bank, and learned that I didn't want to make paper for a living. So I started at a small assembly company, or Steve Fuddles mentioned, assembly house, assembly shop, board stuffer. And started in the accounting group there. I then started my engineering path, where I was playing from behind and trying to figure out what it is that we were doing. And then, much like Paige, I found out that we had another part of the company which made bears printed circuit boards. And that's where the education really got interesting, because chemistry, additive manufacturing, plating, all sorts of things that I knew nothing about, but spent most of my days trying to figure out. And that's what really brought me to IPC as well, because I was trying to figure out where the truth was in good product versus bad product, in good process versus bad process. And those standards really helped eliminate the whoever shouted loudest was right kind of culture that was in the industry in a lot of areas. So that's kind of the brief career path. From there, I've been in the electronic manufacturing services realm for about 25 years. I've been involved with the IPC in some degree for much of that time. And I can tell you that if you start out with the bumpy path like I had and end up as the chairman of the board of the IPC, you probably have even loftier heights ahead of you. So just participating on the call, being here, being interested, being involved and exploring options is definitely a big step in the right direction.
Hi, everyone. My name is Brittany Nelson. I'm a recent graduate of Texas A&M University, where I studied electrical engineering and I minored in math. Currently, I live in Austin, Texas, where I work at Cisco as an electrical product engineer, where I get to work with Cisco's Catalyst 9K enterprise switches, and I work alongside the design engineers in manufacturing to make sure that our PCBAs and our fabs are manufacturable, made on time, and cost efficient. And just like how Dave was kind of talking about in the beginning, I kind of like fell into it. I just kind of dabbled in a lot of different things. And then someone kind of reached out to me on LinkedIn, and it's been history from there, being in the electronics industry.
This has really been an eye-opener. I never thought that this is an industry that you just kind of fall into. But if you would have asked me when I was in high school, what did I want to be when I grew up, I would never imagine that I'd end up working for an aerospace company. So when I graduated high school, I had a completely different track than everybody else. I enlisted in the United States Navy as an aviation electronics technician. And I served a handful of years on board the USS Ronald Reagan and the John C. Stennis, working on helicopters. When I got out of the Navy, I went to Embry-Riddle and I got a degree in aeronautics, so not even an engineering degree. And after my degree, I was like, wow, I should really do something with this. And I heard about this incredible company called Blue Origin, and I applied there as a harnessing technician. So I started off there just building wire harnesses and kind of worked my way up from there. I quickly became the manager of the harness lab. I ran the harness lab for 2 years. That's where I learned about IPC. And then about a year ago, I switched over to become a production engineer, working for the New Shepard rocket. And so now basically when anything goes wrong, they come to me and I tell them how to fix it.
Okay. All right. So I'm going to ask all the panelists if you'll unmute your mics so that you can just shout out if you want to, and I'll know, or you can just raise your hand and we'll recognize you. But so we're going to ask a couple of questions, but for those of you in the audience, if you have a question you'd like to ask of the panelists, feel free to type it into either the chat or the Q&A, and we'll try to get to it as soon as we can. But I'll start off with one, and just if you have an opinion about it, let me know. So if you were in high school or college right now, if you're back as a student and you wanted to get into the electronics space, you wanted to, do more in terms of creating the future, what advice would you give students today? What should they be doing?
I'll start with this one because I am a student. Most colleges, or some colleges now, have the IPC Clubs. Ours is called the IPC and Electronics Club at Michigan Tech. We're good about hosting presentations from industry members as well as making projects. Now we're working on making a PCB ruler for our members to make. It's a good way to connect with like-minded people and to learn from industry professionals. And then to piggyback off that, I would say start asking questions. Ask questions from your professors, ask questions from the people that come and speak to you, ask questions to your senior classmates. That's a good way to learn, and to learn to say, why does it work? And that's really important when you get into industry.
Very good. Anyone else? No other suggestions at all?
I have a little bit of a higher level thinking about it, and that's just always follow your heart and do what you feel is right. You'll end up on a path that you never thought you'd be on, and always never be afraid to ask a stupid question. That's how I get by every day.
Yeah, I think I've got 3 kids in college, so having gone through the late stages of high school recently, relax. Don't put too much pressure on yourself. It's you've heard 8 career paths, and none of them were a straight point from A to B. So don't be afraid to fail. It applies a lot of, in engineering, but on your career path, your life path. Don't put so much pressure on yourself that you've got to have it all figured out at the old age of 17. I think look for opportunities to I think all the advice you're getting is great. Ask questions, get involved. I think if you've got an opportunity, one of the neat things about this industry is almost every region in the country has electronic manufacturing service providers. Some have hundreds, some have 2, but that provides a chance to maybe do an internship. Maybe there's no time for that. Maybe it's just a tour. But get in, get a look at it, get your hands dirty, and really, the more you start to get involved, you'll either be drawn to it, or you'll find that, oh, okay, I don't want to be electrical, I want to be more chemical, or vice versa. The proliferation of the Internet of Things is only having more of these opportunities pop up, and then maybe it's too early, but at some point finding that mentor is just critical. And I think the easiest way to find the mentor is just be the person that the mentor, the mentee want, that they want you become someone that they see something in, and they put their time into investing in you. And you don't have to be the smartest person on the planet. It's just the person that shows up early, works hard, has the right attitude, positive, dedicated, and confident but not arrogant. Just be the person that you would want to work with, and that mentor relationship will hopefully find you.
Very good. We've got a lot of questions coming in. Anybody have any last minutes, something else they want to mention on this before we go to those?
Following Joe, that's kind of like what I've done. I started at the entry level, so there's manufacturing shops like everywhere around where I live. So it's almost like I didn't even know how I didn't know. Like I have like friends whose parents who had it, and I didn't even know what they did. It's like only years after I've been in the industry, I found out a bunch of other people I know are in it. So it's like everywhere. But that's kind of like what I did. I just started at the entry level, and I showed up early. I worked hard. I tried to learn whatever new stuff I could, and then that's how I just kind of rose up to where I am now.
Okay. Let me take this first question from Ivan. He says, is a degree in electrical engineering a bad idea for anyone wanting a job in the microelectronics field? Who has electrical engineering degrees? It's me and Brittany, right? And Paige. So Brittany, why don't you take us there first? The question is it a bad idea for someone wanting a job in the microelectronics field? I already have an associate's degree in electrical and computer engineering, planning on getting a bachelor's or master's in electrical.
Yeah, so honestly, I don't think it's a bad idea from my perspective, even though I'm just kind of like early in my career now. But I think the main part about getting like your electrical engineering degree is learning how to learn. And so once you know like the basic you understand the basics of it, you can take that information and move with it. Like even what Daniel was saying, like he has a psychology degree and he's still in the industry. Like I think it's just like your baseline, and then working from there is all that matters.
Very good. Paige?
Yeah, I agree. And I think it totally depends on what you want to do. If you're interested in something like SMT work, it might be better. Otherwise, I think a chemical engineering degree might pair well if you want to work for a board manufacturer, because you already have that experience in electrical and computer engineering. So it's very dependent on where you want to go and what you want your career to look like.
Yeah, so my opinion, so as an electrical engineer, let me just share just a quick story. When I was working at Bose, my brother-in-law said he was deciding to go into electrical engineering, or considering going into electrical engineering. So I flew him out, had to meet with 12 different people that worked with me. All of them had double E degrees, and all of them were doing vastly different careers. So it's a very flexible major. It allows you to do many different things, whether you have a focus on, doing, high-speed design, all the way to you might be doing purchasing and so an electrical engineering degree is just teaches you a lot of great skills, I found. And Dr. Bose used to always hire electrical engineers to run every department. He had electrical engineers running marketing over at Bose. So it was he was a big believer in that degree. So I think it's definitely worth your time. All right, let me go to the next question. This is from an anonymous person. How is the average workday of a product engineer? What's the average workday of a product engineer like? So product engineers, I think that's Brittany for sure. What's the average day? What's an average day look like?
So it kind of like depends on like week by week. So I'm in charge of like 5 to 6 different like enterprise switches and their like manufacturing process. So I work alongside a lot of like the design engineers. So I see a lot of the design work, and then I also see how that transfers to the manufacturing side. So like some days I will have very slow days because like, oh, we sent it off to the manufacturer, like it's not that much work. But there are other days where we're trying to do like DFM, and we're trying to fix a lot of the problems that we're having. So I may work like 10 hours a day for 1 week, but then it may be like 6 or 7 hours the next week, simply because it's all based off a schedule and it's all different.
Very good. Anybody else have some insights on that, on life as a product engineer?
I think my position is pretty similar. Most days I'm, working from my computer, standard 8 hours a day, just kind of writing work instructions to fix hardware. And then other days I'm crawling around the vehicle trying to find, the discrepancy and finding the root causes. So it's really exciting, and no day is the same.
Very good. Did any of you have any internships that led to your current position or moving into the field?
I can probably chime in for this question because
Go ahead.
I did my internship in Maxing, which is wafer level packaging. And that timeline, I figured, okay, silicon packaging is not like USPS packaging that you wrap up all the products. And that's really fun. And that time I was in school, and I figured, okay, this is something that motivates me really. So after I finished my internship, then I applied for the packaging jobs. So it really like gives you opportunity for the internship that you start open your eyes to the positions, the real positions, instead of something that you didn't really know, and give you all the hands-on experience and see like whether you like it, whether it excites you.
Okay. Joe, were you going to comment on the internships as well?
I
saw you nodding. I'm sorry. If
yeah,
you
yes,
something to share if you don't.
The Douglas Aircraft internship kind of, was helpful from an employer standpoint. I think the summer intern program that we've had, a dozen students through every year for a while. That's been very helpful for us in terms of recruiting, but it's also helps us with, staying, I don't want to say young in the industry, but exposure to new technology and new ways of thinking, and having someone come in and just a fresh set of eyes is huge.
Yeah, I had an internship at General Electric, was one of my first jobs, and ended up working at GE. And actually, that's the first place that I ever laid out a circuit board, was using Mentor graphics program on an Apollo workstation, and living in a cave, that was all dark with, so you could see all 25 different hues of colors there as you're trying to build what was an amazing 8-layer board at the time. And now that's just, routine. So yeah, I think internships do help because at Bose, when we were hiring, when we brought in internships, if you do well at an internship, it's really like the pre-job. If you're asking the right questions, if you're participating and you do well at your internship, the chances of you getting hired on there, if you'd like to be, go way up. And so and when you interview after having had an internship, instead of just talking about your classes, you actually get to talk about real work that you've done. And that's also very appreciated by people who are bringing you in. There's another internship question here just before we leave that topic. It says, how were you able to find internships or jobs that you have today? How were you able to find them, and the skills or criteria that they were looking for when hiring you? So anybody want to talk on the skills or criteria that employers are looking for when hiring, or how to find internships?
Can touch on a little bit. So when I was in school, I had 4 internships at Procter & Gamble and did a co-op at Biomet, which is now part of Zimmer Medical Devices. And so I actually started right after my freshman year with an internship. So different companies are looking for different things, right? Procter & Gamble was not in the electronics industry, but I assume there are other electronics companies that would be the same way as them, where they want to get students that are early on and kind of groom them in their ways and bring them up within the company to eventually become a full-time engineer there. And so, I think they're looking for someone that's eager to learn, has good presentation and interpersonal skills. And then obviously as you get a little bit more experienced, they'll be looking for students that have had applicable coursework, especially if you're going to do something in a lab, like have you used this equipment, basically, so those are some key criteria, I think.
All right. Other thoughts? What people are looking for when hiring, or how to find an internship? One of the, go ahead, Paige, go ahead.
Okay. I think in finding them, career fairs or places like LinkedIn, or we use Handshake a lot at MTU, are great places to start and reach out to recruiters and reach out to engineers and to make those connections. My first one was in my hometown, and they love to see people from their area come and want to work in their industry and see what they do.
Okay. One of the other suggestion I'll just offer, because we've got a lot of questions coming in, I don't know if we're going to get to all of them, but we'll try, is that you can always ask for an internship. I had a friend of ours say, hey, we've got this kid, he's looking for an internship. Do you have one? And we actually created one because the kid was pretty cool. It's like, hey, yeah, well, let's see what it'd be like to have them work for us for the summer. And they did great. So also you can try to create some if you can, Give Joe a call, ask him if he's got an internship available.
And the first thing I would love to see some proactive steps taken to show me that that you're interested. So I went on IPC and took a course on, got a certificate on ESD or something. Any little step that you can take that shows, drive and interest above the pack is going to serve you well.
Great. We have a teacher asking, any ideas on how to keep students to stay motivated with an engineering program?
That's hard. I think it depends on the students. I really enjoy working with my hands, and I enjoyed being hands-on, being in labs, working with actual materials, actual components. And some students really get a kick out of sitting in those classes and solving math problems.
One of the things that we did, like for a project, was there were 3 of us that worked together. So instead of just having to figure it out on your own, partnering up. And so one of us did the digital design, one of us did the analog design, and one of us did the software glue that pulled it all together. And so we kind of had a lot more fun. It's about doing and creating stuff, I think, is another way to help motivate. Other thoughts? All right, here's one. What are some career opportunities related to the music industry and electrical instruments? So I'm thinking, Gia, you and I have this one handed because you're at Apple and I used to be at Bose, and we can talk about music.
Yeah, probably. I think there are a lot of different things on like related to music that Apple is doing. And I think back to the electrical engineering work is that like everything that you think creative and change people's life, or like you think music can bring anything to anyone, then you can turn it on and see whether you can do a real product related to that, or even just a functionality of a part of the product. So it's something like a piece of the ideas that you turn it into real products.
Yeah, and I would just add, so like at Bose, every interview that we did at Bose, they asked if you had a musical background because it was a lot about sound. But if you're interested, go research the companies that you like their products of. If you want to help create, new ones of those, go reach out to Korg or to, Feder Guitar or something, whatever it may be, and say, hey, I'm an electrical engineer. I'd like to get into this area. My brother-in-law, it may not have to be just music. My brother-in-law was an aerospace engineer and loved cycling, and they were looking for an aeronautical engineer to help design better bikes. And so now he works for a bike company in Colorado, and I don't know that they're going to get them off the planet, but they're pretty cool bikes.
I think there seem to be a lot of questions regarding dual degrees, mechanical, liberal arts, and engineering. I think that's an interesting place to talk a little bit about the difference that I've seen in the electronic manufacturing services business and the OEM. the OEM world, it seems that you've got, maybe you've got 1 billion potential customers. Your customers typically coming through the marketing organization's feedback loop. On the electronic manufacturing services side, you've got customer feedback loops of minutes, not years, to see if your product is going to be, accepted by the marketplace. You get exposure to so many different applications in the electronic manufacturing services side. In the morning, you might be working on a project that is for Brittany, and you're doing, networking and telecom equipment, and then you're going to be pulled into a meeting on a new product introduction for an aerospace company, and then in the afternoon you've got some failure analysis on some musical equipment. You're going to have, a broad range, and it's not a bad way to get exposure to a lot of different businesses and a lot of different industries, and you might get addicted to that kind of level of change, or you might say, oh, that industry sector is a great place for me to take my next step with an OEM.
Yeah. Any other comments on dual degrees or non-traditional students? I mean, I'm still trying to figure out what I'm going to be when I grow up. I mean, I started off with a double E, got an MBA, got a doctorate in education. I enjoy music. I do all kinds of things. And so I think the more diverse your interests can be, the more you can delve into the creative and pull out different solutions to the problems. And that's really what all this is about, right? You're trying to solve a problem. You're saying, okay, I don't want to just listen to one song on a record and then flip it over. I want to have 47,000 songs in my pocket at all times and be able to listen to whatever I want, whatever mood I'm in. So that's a problem. And then we're trying to solve it. And you create devices as you go forward on that. Here's the question about starting your own company during your career. And do you see opportunities to start your own company during your career? What would that company look like? Any of you seen any of that going on? It kind of ebbs and flows. I remember when I joined Bose, I found it fascinating that there were a bunch of engineers that were also joining around the same time I did, who had already worked there for 10 years and left for 2 or 3 to go do their own thing and then came back to the industry. Others took off and did their own thing. So I think if you're going to go do that, early is not a bad time to do it. You have less responsibilities. You're not saying, oh, I bought a house and now I've got a house payment I've got to make, or things like that. So experiment early, and you can always have things going on the side to keep the skills up. And even if it doesn't pan out and become the next, maybe you're not the next Steve Jobs at Apple or something like that out of your garage, but you'll learn things all the time, and those skills will help you at whatever career you're at. Other comments? Anybody see anything on that? All right, I'm going to keep going.
I'll just chime in on the. I've started a few and bought and sold about a dozen companies in the career. But I think the exciting part right now, and I'm too old to do it, but the automation, the artificial intelligence, the revolution that's coming to the manufacturing industry is going to be led by you guys. And it's exciting, and it's the variability of human hands on these processes is amazing. So you've got you've got your wafer manufacturing, 100% automated, very standardized form factors and sizes, and very high yields. And then you take that and you go to the printed circuit board fabrication, and it's very much in its infancy in terms of standardization and automation. And then you take that to the assembly operation, and you've got very automated surface mount processes. But every project we see is 100% service mount except for the other stuff. And it's that other stuff that gets you. And so the robotics, all of that is still emerging, and I think very exciting. And I think that's the part that would draw me into the industry if I were a younger person.
Gotcha. Let me turn this question to Christina, Daniel, and Sarah. It says, if you have an idea, is it easy to discuss those ideas with your superior, or do you pitch an idea to your immediate team you're working with? Do you work mostly alone or with a team? So just talk a little bit about the work environment and how you share ideas.
Can I start with that one?
Sure, go ahead.
So one of the things that impressed me the most at my current position or my current company was that anybody at any stage could pitch an idea to anybody, and everyone's always willing to listen and really give you your time of day. I work mostly with a team, which is great. So there's engineers of all different types. So if I ever have a question about structures or fluids, I can go over and ask them. We're very collaborative.
Awesome. Daniel or Sarah?
Yeah, same. So I work like kind of half and half. There are times where I just kind of want to box myself in a little closet or something like that just to work. But for the most part, you know, like my boss, he's very receptive. The people I work with, they're all very receptive. We'll just kind of like sit down and try to hash out a problem. I feel like that's how you learn too. I've learned so much just from sitting down and just trying to tackle a solution. Something I thought was a great idea, I found out it wasn't, or vice versa with some other people. And it's pretty easy. Yeah, everybody that I've worked with has been just a joy to work with, and they're all really easy in tackling issues.
All right, Sarah?
Yeah, my job's a little bit different, right? So I'm a reliability engineer for PCB. So there's a few of us because we have so many printed circuit boards to manage. So we kind of work as a team to bounce ideas off each other. If I have a new way of, hey, this would be more efficient, we should do it this way. And, you know, we kind of work together and come up with things like that. But I also work with manufacturers, and when we have an issue, we brainstorm and work together to solve that. But I do have ownership, you know, so I'm leading the quality for this project, right? So it's a team setting, but I have ownership of something which you know, makes you feel good, gives you the feeling like you're contributing and making a difference. So I think it is important to have a little bit of your own piece of something to work on.
Very good, thank you. We've got a ton more questions and not a ton of time, so I'm going to go with one last question, and we're going to go around to each panelist and ask their opinion to this one because I'm curious about it myself. The question is, what surprised you most at your first engineering job or internship? And I'm just going to take it away the way it comes on the panel here. So Sarah, we're going to go right back to you first.
Yeah, so
what did you find most surprising?
I was kind of surprised. So they asked me to create my own objective. So in school, here's your assignment. You do this, okay? You did well. You get an A. But in the real world, you have a rough idea of what you're supposed to be doing. That's your job, like description. But then you actually set your own objectives, and it's up to you to define what those will exactly be. So you can kind of create what your exact job is and what you want to be known for. And I thought that was going to be more prescribed to me by my boss, but that's not how it is.
Wow, great. Paige.
I kind of agree. The autonomy really shocked me. They were like, well, just go do it. Go walk around the floor, figure out what you need to figure out, get what you need to get, and get the job done. And in school, they kind of hold your hand a little bit more with that.
Okay. Gia?
Yeah, I want to share my experience because my first internship is in the wafer level packaging. And I was surprised that in order to get into the clean room, you wear the bunny suits. So that takes me like the very first time, I think 10 minutes at least to learn how to get on the bunny suit. Because I never see that before. And I was surprised like, oh, they need to control the clean room that much without any dust, without anything. And they blow you before you entering the clean room. So this really like surprising experience for my very first job.
Very good. Daniel.
Well, I guess considering from where I started at the beginning of the career, just kind of getting behind this, behind the scenes on the floor, it was just kind of eye-opening seeing how much there was out there, and just like just looking at like how much stuff was going into it. Like there's so much stuff I didn't know. Like just about certain of the manufacturing stuff that I like to share with the other people, because they, I don't know, it was just all very new to me. Things that I didn't know, like things that I used in other areas, like Excel and just formula building, and just kind of how that helped me out in certain other areas that I didn't even think it would help me out. It's just like kind of everything kind of builds up onto each other.
All right, thank you. Joe?
I think the similar to Daniel in that the amount of work that needs to be done is incredible, and I think that helps lend itself to the access to make a difference in the company. You know, no one's. This industry is very, it seems very data driven, and there isn't a lot of room for politics, right? It's not a game that's played based on you know, where your office is. If you've got a better solution, this industry is going to embrace it. And you know, and to Paige's point, the reward for hard work is probably more hard work, but you know, you're going to get more projects, and the challenges are never ending.
Very good. Thank you, Joe. Brittany?
Yeah, to kind of go off of what Joe and Daniel said, I think it's just the vast amount of knowledge that's really out there. I think electrical engineering set me up for like the foundations of like the industry. But like once I started working, I was like, wow, there's so much more that I still need to learn, and so much more I need to do. And kind of just most of my day is spent half of learning and half of like actually doing my job. And one of my mentors actually told me that every day you should always strive to learn at least one thing each day. So it's kind of been just like I'm constantly learning, and that's something I just never thought I would actually be doing.
Cool. Very good. Thanks, Brittany. And Christina?
The thing that surprised me the most is actually like the flexibility about the career of being an engineer. So in my previous life as a, you know, enlisted sailor or as a technician, it's very rigid. You show up at this time, your break is at this time, and you know, that's your whole day right there. And then as an engineer, it's kind of a lot more flexible. When you wake up and you're ready to come on in, and we really just focus on getting the work done. So you could end up working 10 hours a day or 8 or less, but it's really it's more focused about delivery and actually putting your heart and soul into your job as opposed to rigid work hours.
Very good. Thanks, Christina. So the thing that I would share was the most surprising to me was the level of teamwork and collaboration. In my senior year in university, I had a final exam, and it was given to us as teams. He gave us all 7 questions before the exam. We knew what the questions were going to be, and we had to present. He set up a desk on the side with snacks, and it was basically you were presenting your solution to the rest of your classmates, and they voted on, you know, they asked questions, and it was very realistic. And when I got into the industry, that's exactly how it is. It's not like, oh, I did this, look at me, oh, I got an A. There is no A for an individual. You work together as a team to solve whatever challenge you're being faced with. And so I thought it was an interesting way to give a final. And then once I got into industry, I was like, wow, that's exactly how it is every day. Even with the snack table. All right, so panelists, thank you very much for your time today. I know we've only got a few minutes left, and Aaron has the next segment, but I just wanted to thank you all, and I'll turn it over to Aaron.
I appreciate it. And thanks everybody to panelists, those who asked questions. I'm going to give a brief overview, and then I'll get into the fun of our giveaways. So if you bear with me a few minutes, you may win a prize. I'm just going to touch on some of the things the foundation does, what you can do from here to learn more about the programs we have and how you can continue the conversation. So the bulk of our programs revolve around high schools and and colleges right now. But we do have a couple other things. So this was our version of our STEM event. Here's a few photos that we've done in the past. And we do intend and hope to launch this again at IPC's Apex Expo next year in San Diego, typically held in Southern California. So the students that happen to be in that proximity get a little extra benefit, but we are rolling out programs all over the country pretty soon in the form of virtual learning. So this is a way to get students interested get your toes wet, get some hands-on education and virtual education to the students. So if you're an instructor, CT instructor watching, or you have students who may be interested, we'll follow up and provide some more information if you would like to offer this to your students. And then for colleges, for both universities and community colleges, we have an IPC student chapter program. This is more my personal domain. And Paige touched on this. If you caught it during the presentation, she's the chapter president and actually has a special role on IPC's board of directors as part of it too. But the premise is to get students connected to the industry. So we have education that brings them up to speed on electronics, electronics manufacturing, assembly, and the introductory level materials. And today is an example of an event to bridge students with the companies. IPC is a membership trade association with thousands of companies worldwide. And part of the student chapter program is connecting those students to those potential companies that they ultimately want to work for. And we also have some projects more rolled out in the future. And we wanted to launch them this year, but without as much in-person events, it was a little tougher. So stay tuned for that. But we were able to launch a really good scholarship program where we gave 25 students at our universities $1,000 scholarships. So something that the students can directly benefit from and certainly push them to further their education. And a lot of students used it on professional and personal development in the industry. Here's a quick shot of where we have our chapters now. So you can see both community colleges, high-level universities, and everywhere in between. And part of the reason is because there's such a broad type of individual and education level that I don't have too much more time here, but there's no restriction on majors, as I mentioned, and just here's a quick snapshot. And to make sure that we get to our giveaways, just another quick thing. Here are some of the programs that we do with high school. So we do have the virtual education, as I mentioned, and we also have some projects. We're reworking these to coordinate with our virtual education. So again, if you're a CT instructor, stay tuned. And we will move on to this. So this is the fun part. I have randomly drawn 10 names.
Thanks for using that picture, Aaron. That's great.
It was fun. I hope I got some smiles. I can't see it in person, but I laughed. So we have Bose Bluetooth headphones donated by Bose, and then Apple. We will provide 2 AirPods with charging cases. So I'm going to read 10 names, and if you are a CT instructor and you have a class, you're welcome to give out the prize as you wish. That's just on you.
By the way, just a comment on the Bose build Bluetooth headphones. They're actually a project. You build the headphones in this kit.
Yeah. It's so all the pieces come disassembled, and there's a Bose app, and you go through and you mess around with frequencies, waves, all that kind of stuff. You can design. So it's a learning experience, and they're also really high quality headphones that you end up with. So I'm going to go through here, and I hope that the people that I drew a few minutes ago are still on the call. The first 2 winners will receive the Apple AirPods, and the other 8 winners will receive Bose Bluetooth headphones. And I will follow up with you via email on how to ship those to you. So virtual drum roll, please. Winner number, oh, that actually heard something. Winner number 1, Anthony Zangaro. Congratulations. Oops, sorry, hit my mouse.
It looks like he's still on too, Anthony. Great, good job.
Great. Winner number 2, Desiree Wilson.
Desiree?
Several.
I think she's got some classes.
Right, so I did check. I believe she's an instructor, so
we'll ship them to you, and you can determine which students participated the best to give them to.
Sounds good. All right, winner number 3, Heather Schlinker.
Looks like Heather's on as well.
Wonderful. Winner number 4, Madeline Kohler.
Yep, Madeline's on.
Fantastic. Winner number 5, Ricardo Rodriguez.
Ricardo Rodriguez, yep, he's on as well.
Fantastic. Winner number 6, Phil Crawford.
Phil Crawford. I don't see Phil Crawford. Did you say Phil? Like
I said Phil Crawford. Okay. Sorry to Phil. I do have some backups, so we're good to go. Should we give him to Phil, or should we?
I don't see him on here. Let's keep going. See if we can get people that are on.
All right, sounds good. So winner number 6, number 2, Ethan Grabowski.
Ethan is on here. Good.
Wonderful. Congratulations, Ethan. Winner number 7, Sandro Figueroa.
I don't see. Oh yeah, Sandro Figueroa. He's on here. Or
Fantastic.
Sandro. I don't know if that's a. Madeline wrote she doesn't know how we get the prize. We'll contact you via email and ask for. We'll ship it to you.
Correct. All right. Winner number 8, Arnolfo Silva.
Sorry, say that one again.
Arnolfo Silva.
Arnolfo. Yep, there he is.
I see him. Congratulations. All right. Winner number 9, Norma Malone. Are they still on?
You see it? See the name on here?
She must have recently left.
Okay.
Okay.
Try
So
again.
winner number 9 times 2, Michael Sarasso.
Yep, Michael's on.
Wonderful. And our last winner, if he is on, Sean McConnell.
Sean McConnell is on.
Okay. We have our winners. Congratulations, everybody. Thank you for joining. We appreciate you being on this long.
Thank you, everyone. We're out of time. We've used our hour and a half, and we will be rebroadcasting this as well. So if you have classes or other colleagues that you think might benefit from this, stay tuned at ipcef.org, and they'll let you know when the other rebroadcasts will be happening. Or just reach out and email Aaron directly, and he'll let you know. Thank you, everyone.
Thank you. Take care.
Bye-bye.